went from making 60 grand a year to 450 grand per year as a data engineer in less than 5 years' time. I started my career at Amazon. I went to Lyft, and I was able to work with a few startups in between. And every single time I jumped to a different company, I made an extra 20, 40, 60% more in my compensation as a data engineer. And the thing that most people get wrong is that they think they just need to learn a bunch of tools. What they don't realize is learning projects so they can see how those tools operate is a way better system, because then you can talk about these projects and the real business impact that these tools have when you actually get on an interview, and also when you present your resume and are applying to a bunch of jobs to hiring managers and to recruiters. So in this next video, we have created a project for you to enjoy. And if you do, then please subscribe, like, click on the link below, write in the comments so that you can suggest any more videos that you want us to create, because our goal is to create as many videos as we can for you for free so that we can upload it to YouTube and so that you can enjoy. Other than that, enjoy the project and enjoy the free video. Cheers.
It's kind of like between what we do and this level up, little up and down. Anyway, in between. But system design, as you said, you're going to like put those questions on the make it available on our website or DA's Academy's website. Maybe we can go from there. But aside from that, I do have a questions about deep data engineering AI. Is it not something kind of Databricks already has it, or Snowflake has it as an embedded system within their environment?
What kind of thing that Databricks and Snowflake doesn't have? I didn't get the first part of the question.
No. I said, as you mentioned that, like data engineering AI. My understanding was, what Databricks offers or Snowflake offers. It already has some embedded AI technology in. So when you're speaking about like data engineering AI, what else beside Databricks has to offer you would cover?
Yep, there are a lot of other things. You can use Snowflake and Databricks, not a problem. But there are a lot of other things which are required apart from just these services. Okay, so let me do one thing. Let's get.
Sure, if you speak a little bit about this concept. So.
Yep. So yeah, that's what data engineering in AI would be about. It would require a lot of other things, but yes, let me start here. So let's take a problem statement, guys, and let's try to solve it together. And I think that was the first question on how would you answer the interview questions, and then we can go through the data engineering in AI stuff, right? So let me share my screen.
If I rephrase the questions, how would you differentiate it from those two aspects? Sorry, that would be same thing.
Hold on. Let me know if my screen is visible.
Yes, I can see.
Okay, cool. Let's create a new whiteboard today. Okay, so data engineering in AI, right? This is going to something new for you guys. Okay. So don't be confused. Data engineering in AI. Okay, cool. So what do you guys think is data engineering in AI? Any idea? Anyone has any idea who has been going through our AI courses or anything? What's data engineering in AI? Or what is, let's first try to understand what is AI in plain English and what is DE, and then let's try to mix these two.
Just to clarify, Ninad, are we trying to discuss AI in data engineering or data engineering in AI?
Data engineering in AI.
Okay, that's interesting.
Not AI in data engineering.
Well, AI is a predictive model based upon a prompt. It predicts what it should respond based upon the information it has already encoded in its, because it only reads, it only encodes as it goes through. It only decodes as it runs through. It doesn't encode new information and send it out. So it's only as predictive as what your prompt is.
Got it. Okay, cool.
With these large language models. Yeah.
I would like to add a little more about, what Rick said. He's right. I mean, in my understanding that, just the plain English, artificial intelligence, right? It would act like as a human being, but meaning it has a lot to, deal with what do you call logics and other things. It can be teachable. You can kind of model it. You can kind of teach AI what to do with. Let's say I'm a writer, right? If I teach this technology now, it can do tasks for me. We can automate tasks. And honestly, I myself was thinking, making. Anyway, that's a different world things. I've been using this technology, for quite some time in my personal to business level, or even in my previous job, I was using it. I was using back propagation.
I think let's do one thing.
logic.
Let's stick on AI. Like you said, AI, a simple system. Like you guys said, yes, both of you guys are right.
It can do tons of things. Yeah, go ahead.
Yep.
Go ahead.
Ton of things. Human intelligence, machines can solve our problems. It can decide, it can recognize patterns, it can predict. But there is something before doing this, it needs to process vast amount of data. Okay.
Yeah.
And that's where
it gets weighted as it learns. It gets weighted and
Neural networks.
It comes through neural networks. It gets data in tensors.
Yep. So okay, we don't want to get that complicated. Let's forget all those things.
Yeah. Okay.
Right? Simple things. We are first trying to understand what is DE in AI. Okay, there are two concepts: AI in data engineering and data engineering in AI. Okay. So AI requires vast amount of data, correct?
Yes.
Now, that vast amount of data is processed to the data engineering team. And that's what your data engineering in AI is. As simple as that. Okay. I'm not going to tell you today how to use AI for data engineering tasks. I'm going to show you how data engineering is done into Gen AI projects. I know a lot of data engineering vacancies these days are asking for some Gen AI experience. If you've done any unstructured data processing, if you have done any image-based data processing or text-based data processing, right? That is the kind of thing. So let's take an example of RAG. Does anyone know what is RAG? Retrieval Augmented
Generation.
Yes.
Sorry.
Yeah, retrieval augmented generation.
Yep.
I have a bit of idea, but
Retrieval augmented generation. What is this? A normal chat GPT, but on your company's own data. Okay. So let's take DEA's example. I don't know if you guys know, we have a Support Genie app installed in your Slack channels. Okay.
Yep.
Support Genie is nothing but a bot that answers any SQL or Python questions for now. SQL or Python questions. And it is trained on DEA's content. So if you ask any question from our portal related to SQL and Python, if you don't understand any question or solution, you can ask that bot and bot can answer you. Does it sound fancy? Like any company, they use GenAI, they pass their internal documents and you can ask questions and you get an answer on top of that. That's what simple RAG is. Any questions, guys? Anything around RAG? Do you understand what is RAG now?
I don't think I do understand entirely what RAG is completely.
I think this is similar to Microsoft Copilot, right?
Copilot is a bit different. Copilot is a bit different. This is a process, okay? This is a technique in GenAI where you use large language models like OpenAI's large language model, like, ChatGPT. You can use any Sonnet, Claude, Amazon's Titan. I think there was one model from Meta as well. But yeah, you can use any model.
Sorry, I was just kind of curious. Where does all this, whatever it is, like, where is it all stored that it's able to generate the text that it does?
Yep, I'm gonna come back to that. That's where the system design comes in.
Okay.
Okay, cool. Now everybody knows what's RAG. So if you want to try, just go to Support Genie in your channel, tag Support Genie and ask any question related to SQL and Python. I haven't added all the documents yet, but we will be adding it pretty soon. You ask a question, you get an answer. That's it. But let's say you need to ask a question which is internally with respect to any company or with respect to a product. Then ChatGPT cannot answer your question.
Nina, I got a quick questions right here. Just to observe myself. So it will answer based on what resources you supply are, right? Based on the answer you provide that you provided previously through the system or through the RAG or whatever, right?
Yes. I think that's the second part. First thing, you need to understand what is RAG. Answer part is the second part.
So it's customer specific, right? Like AI agent, chatbot.
Exactly. I mean, not agent. It's not an agent. That is the confusion I want to clear, guys. AI agents are workflows.
Yep.
Okay. It can do automated tasks for you.
That's the
RAG is nothing but, let's say you have a UI. Okay. You ask a question. Okay. This is your internal ChatGPT. Okay. You can ask a question here and you get an answer over here.
Yeah.
As simple as that. The only thing is, let's say, you want to ask any question related to Data Engineer Academy. ChatGPT won't have that answer, correct? So what we do is, we take internal documents. Okay. We pass it to large language models and we get the answer. Is it simple enough, good enough to understand what is RAG, guys? I mean, you can ask any questions if you don't understand.
For me, yeah, I do.
What about other people? Do you guys understand?
Yes.
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 Okay, cool. Moving ahead. You have internal docs, you have LLM, and then you get an answer. Looks pretty simple and straightforward, right? Now let's come into system design or a bit complex side. So,
Question. Sorry.
mhm,
So when you say internal documents, what
mhm.
would be like what kind of internal docs?
They can be PDF, docx, docs, images.
Okay.
It can be anything, text files, JSON. You can add anything, Parquet, CSV, whatever you need.
And based
Okay.
on that documents, LLM will create answer.
Correct, exactly.
And what's LLM again?
You can use any LLMs. You can use OpenAI, Claude, Sonnet, Amazon Titan, Meta's LLM. Any LLM that has an API, you can use it. Not a problem at all.
So it's like internal versus external. If this document was publicly accessible, ChatGPT can get that one and provide.
Exactly.
Yeah.
Yep. But
Is there like a structure to how the whatever text is stored? Is there like some kind of structure to it?
I'll come to that part, and that's where data engineering AI is important, because this is unstructured data. It cannot be structured. Like PDFs, docs, images, they cannot be structured. Text files, correct? And that is where your data engineering in AI comes into picture. Okay.
So is that the reason why vector databases like Pinecone are used?
That is just one part of it, but it doesn't structuralize the data. It's still unstructured.
Nina, so the whole process of converting these internal docs to feeding to LLM and then getting answers, that whole process combined is done by RAG?
Yes, that is what we call a RAG concept. Okay. Now, if I have to double click, just to
I think
answer your
it's not
question.
bad, but for, isn't it like for? You design for the RAG, but you're what new material your LLM is learning.
Sorry, I didn't get your question.
It's not by RAG because isn't it for RAG? You're doing a pipeline to create RAG to update your model with newer information.
Yeah, I mean, that's what you call retrieval augmented generation, when you generate an answer, correct? With the help of LLM models by passing your internal documents. I'm telling you it in plain English. We will double click into it, okay? I'm explaining it for those who don't understand what RAG is, okay?
Yeah. Text files are unstructured?
Yes, they can be structured, unstructured, both, anything.
Okay. I could see like images would be I would think are unstructured. I just didn't see how text files were.
Yep, they will be.
They're one big string it sometimes, and other times they're not. They're comma separated values or something, but they're not always.
Damn, why am I missing the spelling? Sorry. So, let's try to dig deep into RAG. I think someone asked us. We pass the question to LLM and we get the answer, right? So I'll give you how exactly the system works. User asks a query on ChatGPT. That query goes into a processing layer. It retrieves relevant documents from your database. Okay, because it's going to be internal documents, correct? The example I gave you, Data Engineer Academy SQL and Python courses, which are available on the portal. We have entire documents created for them. I'm going to show you the examples as well, all those things. Don't worry about that. You retrieve the relevant documents, actually. Retrieve relevant documents. You either get the summary or entire document. That is your context, actually. You pass it to LLM, and LLM gives you the answer. Okay. This is the entire system of the RAG. You get a query, query processing, relevant documents, summary context, LLM, answer. This is how RAG works in background. Okay. But this is where data engineering comes into picture. Whenever a database comes in, data engineering comes in. Okay. And this entire pipeline can also build using data engineering and software engineering principles. Software engineering and data engineering principles. Or software engineering principles. How? I'll show you that. Okay. Any questions until here? We are clear what is RAG, guys?
Hey, real quick. If you are looking to land a higher paying data role, then there will be a link in the description or in the comment section for you to fill out a form and then book a call with my team who has already helped over 2,000 people get a higher paying data role. And we hope that you are the next person that we help. And so all you have to do is click on the link below. And if you don't want to help, no worries at all. Keep watching the video, keep enjoying it. And yeah, let's go back to the video now. Cheers.
Cool.
There's like different types of RAG.
Yes, there are a lot of types of RAGs.
Okay.
Yep. So, just give me a minute. Sorry. Yeah, there are different types of RAG. I mean, we have explained a lot of things into our GenAI module. So, GenAI project, there is like agentic RAG. I think there is self RAG. There is RAG fusion, naive RAG, hybrid RAG. So multiple kind of things, multimodal RAG, hypothetical document embeddings RAG. I don't want to get into that as of now. I'm just going to explain you the system design and the data engineering stuff into GenAI. That is why I've taken an example of RAG, because that is mostly popular into most of the companies. And that is why I'm going to show you example of the RAG. Okay. Now, you guys are aware of what is RAG. Simply you ask a question, you get an answer. Okay. But the problem is now, all your documents, internal documents, I'm going to take the example, are either in your Google Drive or S3 or some other storage. Okay. All these documents need to be sent to LLM to get an answer, correct? Now tell me one thing, guys. Let's say I have 1 TB worth of documents. Okay. Let's say MD comes in. MD asks a question. Explain where condition.
Okay.
Okay. So I have 1 TB worth of documents. Will I send all of them to my LLM?
No.
What should I be doing here in this case?
The portion of it, whatever the question is asked for it, like explain, I mean, just the needed information.
I mean, the keyword where, explain,
okay,
and compare.
Whatever statement satisfies the where clause or condition, only those portion of the information will go through large language model, LLM. Yeah.
Okay.
That's my observations. Yep.
Okay. Anyone else want to give it a try? Do we pass all the documents, or what is that exactly?
Anything that's related to the main keyword, which is where.
Okay, cool.
Will be required.
Great thinking as a human. Think as a machine. See, in 1 TB, there can be millions of documents. This where word doesn't just mean SQL, correct? It can mean a normal where word as well.
Yeah, in high level language.
There can be thousands of documents where you have a where keyword. Are you going to pass all those 1,000 into your LLM?
No.
machine won't understand if this where document is related to SQL or if it's related to, let's say you have this kind of thing. So you have
So
document 1, document 2, document 3, and
filter.
end document. Sorry?
It's a filter.
Yep. So let's say this is related to SQL, this is related to HR, and this is related to operations. Okay. There are multiple documents. Your target is to pass only this document to your LLM, correct? Now, this entire thing, whatever I'm explaining you, all these things falls into data engineering in GenAI.
Okay.
Okay. Keyword based is right, but it doesn't work into RAG based systems. This was the age before LLM. That's where those normal chatbots worked with based on keywords. Okay. As of now, these words are actually converted into a vector of numbers, 0, 0, 1, 0 kind of thing. Okay. Because you need to find the similarities.
In the encoding, yeah.
You need to find the similarities.
Binary form.
Sorry? We call it embeddings. But don't worry about that part. I'll come there. I don't want to complicate the things. But yes. So you guys understood. You have thousands of documents, 1 TB worth of documents. You need specific documents that needs to be sent to LLMs. How would you do that? That is the question now. Okay. And that's where your data engineering comes into picture now. Okay. That's where your data engineering comes into picture. Okay. Kind
of a data inspector, data validator, or how you
not really.
I'm just kidding.
Yep. No, not really. So let's take a step back. You have 1 TB worth of documents. Before passing it into LLM, you need to store it into a database. Now, anyone in call might say, let's store it in Snowflake. Let's store it in Databricks. Let's store it in Redshift, correct? That's the first question. That's the first answer from any data engineer. But remember, guys, we are storing unstructured data. Okay. Now, every database might claim that you can store unstructured data into their, database, which is true, but not 100% right. There is a difference between true and right. Okay. What happens is when you ask a question in RAG, your question is converted into embeddings. Okay, embeddings is nothing but a vector. A vector is nothing but a numerical vector. You might have learned it in maths, not gonna get complex maths, 0, 1, 1, 1, 0 kind of thing. You get a number like this.
Yeah.
Okay.
In a binary format?
Yes, kind of. Depends again. Not every database follows binary. You can get it as -2, -3, 4, 5 as well. Okay. But at the end of the day, it ranges from 0 to 1. Right, at the end of the day, when the conversion in transformers happen, it ends up into 0 to 1. But yes, that is 3D model. So let's take an example of, okay, we get an embeddings. Now what happens is you have 1 TB worth of documents. These documents are also converted into embeddings. Every document will have its embedding and it will be stored into some database. And that's where I think someone said vector database, correct? Okay. So these embeddings, they can be stored in Snowflake. They can be stored in Databricks as well. Or you can use vector databases. Okay. Vector databases are designed for this use case specifically for storing the embeddings and finding the relevant embeddings. Example, a very classic example. a king. Sorry. You have a king. Let me draw it here. You have king, boy, wing, girl. Oops. Okay. So what happens is when these words are converted into vectors, these numbers are actually stored in this fashion 0, 3, 1, 0. And similar here 0, 1, 1, 0. Let's say this is 1, 1, 0, 0. So what happens is whenever a word is compared into vector databases, so let's say who is the king? This is the question. This is converted into embeddings. It goes to your vector database and it tries to find the relevant vectors. So if the king word has 0, 1, 3, 1, 0, it finds similar vectors like king and boy are similar things, correct? So it's going to pick up this thing as well. So whatever is related to king, whatever is related to who is the king, all those embeddings are going to be ingested and then they are sent as a context into LLM.
Okay, I have a question with this.
Mm-hmm.
How do they get those numbers? And like, how are those decided?
Got it. That's where your data engineering comes into picture. So what you do is you get your 1 TB worth of documents. Okay. Now that is the entire data engineering process. So that's where DE team comes into picture. Your first step as a data engineer, guys, what is the first step? Tell me. Like you have 1 TB worth of documents.
To ingest.
Exactly.
Extract the data.
Ingest or extract. Correct. Now, instead of RDBMS or structured, this time you have unstructured data. So let's say you have PDF, you have images. No, I don't want to get into images for now. Let's forget that. That is a multimodal. Images, text, and docs. Okay.
Yep.
Like you guys said, we have ingestion first, correct? Then we have loading, and then we have transformation, correct?
Yes.
This transformation is nothing but the embedding and all those things, which includes chunking and embedding. Loading is actually, in this case, you don't do actually ELT, you do ETL. This is into vector database. Okay, there is no raw database, there is no bronze, silver, gold kind of things here. Okay, but yes, it's coming in near future. It's still raw. I mean, sorry, the industry is very raw. It is not yet progressed at the level of data warehousing or data lake concepts. But I'll tell you what I think of whenever I do the data engineering stuff for the GenAI projects. Okay, but usually you do ETL or ELT, correct? Now, the first question is, let's say you have your documents into Google Drive. Okay, all the documents are sitting into Google Drive. That's what happened for DEA. Okay, first question, how would you extract? Okay, before extraction, now this is the system design question, guys. You have your documents into Drive. Okay, and I did explain you what we are going to do. We are going to do some transformation and then we are going to store it into a database. Okay, sorry. What would be the first thing you would do in a system design, guys? Anyone?
What's the first thing?
Mm-hmm.
What's the first thing you were saying to do with what?
In a system
Designing
design.
tables.
No, designing this entire system.
Identify the source.
Functional requirements.
Sorry, what is that?
Identify the source.
Design the model.
Design what model?
Of the ingestion extract.
Understand the data source, which is
Correct.
Yeah, identify the data source to ingest from.
Yep. Because you're going to ingest from that source, right?
I think you gotta, based off the requirement, we gotta figure out the data, model data pipelines, right? Or ETL. I mean, extraction and ETL. Yes, in that sort, right?
No, don't make it complex, guys. Don't make it complex.
Okay. Simple.
Keep it
Define
simple.
the functional requirements.
Yep. Like, see, data engineering is common across any industry or any zones, like data engineering, normal data engineering, or GenAI as well, right? You understand the source. Okay, cool. You guys said you're going to extract it. Extract it where and how? These are the two questions you need to ask yourself, correct? Whenever you're doing normal RDBMS, API-based sources, Kafka-based sources, or any real-time sources or batch processing, you ask these questions, right?
Yes.
How would you extract and where would you extract? Like extract and you'll have to load it somewhere, correct? For landing area, landing zone. That's
Right.
what you do in every other project. Right? Now, the only thing is, for you, the documents can be, let's say we are taking Google Drive for now, okay? Where would you take the documents from and how would you take them and where would you load them?
To some data warehouse.
Okay, cool. See, whenever, if you guys remember, whenever you were doing RDBMS based ingestion, you were getting the data, you were loading into S3 and then loading into your database, correct? Because you kept a landing area. Were you directly storing it in
So
your
are we
data
copying
warehouse?
the raw files into that landing area, or are we translating them into something in the landing area?
No, landing area is just copy.
Yeah, but it doesn't matter
Thank
what format we copy them into.
No, because landing area is like a base camp. It's a standardized starting point. Okay. So every time, whenever you were designing your data engineering pipelines, you were just ingesting and keeping it for some time before copying it into your database, correct?
Mhm.
Yes.
So if it's raw text files, we just copy over the raw text files. But if it extracts from another database, we have to load it into a database. But all that's just what we get is what we keep.
No, my suggestion is for a good data engineer, may it be database, may it be API, may it be Kafka, may it be text files, keep a landing area. Okay. The reason I'm telling you keep the landing area, let's say you have a glue job or a Databricks job or whatever job. You extracted the data from source and you're trying to write it into your data warehouse or any database or whatever you call it, or data lake, right? And let's say your job fails while writing here. Okay. You will lose the data. That is the reason I'm asking you to add a landing zone to decouple the system. Try to decouple the system. Okay.
So copy
That
it
way,
to theirs and then translate it into your final source.
transform is later. This is first just loading. Transform is later part.
So
This is
Nina,
from
my understanding. So these are the area can be S3 bucket or some other sources can be used as the landing zone then?
yeah, most of the times you either use AWS S3 or Azure ADLS Gen 2.
Okay.
Right.
Okay. Thanks.
So, yep, that's right. Now, coming back to GenAI use case. You have documents, correct? You have extracted them. What's the next step, guys? How and where? Now we understood.
Analyze.
Now we understood where part, right? We're going to extract them from Drive. We're going to keep them for some time in S3. Okay, because S3 can handle any kind of data. Another reason to use S3. I think
Mhm.
someone said data warehouse, right?
Mhm.
Your every data warehouse cannot handle images, videos, text, or documents.
No, that's the last part.
All right. That is the reason S3 is a good option over here. Now, the question still remains of how. How would you ingest it from
I think you
drive?
mentioned AWS Glue might be an example of moving data from wherever we're getting it into the S3, right? You can use the Glue.
Okay, cool.
AWS Glue.
Or what is Kinesis?
Or maybe Spark.
Kinesis, yes. Yeah.
We can use Python locally and connect to Drive.
Okay, cool. I think I got AWS Glue. We got Kinesis, which is wrong. Okay, I'll come back to that. Python on local. Good for testing, but you cannot use it in production. So that's why I'll cancel this. Okay.
Would Spark be one?
Sorry, what is that?
Spark.
Spark needs to run
Apache
somewhere,
Spark.
right? Spark is a cluster. I mean, Spark cluster. Where would you run it?
Lambda.
Can we use Lambda? Yeah. Can we use Lambda?
Lambda?
Okay, you can use AWS Lambda. But remember, I mean, Spark cannot run on AWS Lambda. Spark can run on AWS Glue. Spark can run on EMR, Databricks, anything, right? Okay, cool. So you got an idea. You just need a
Any kind of
compute where you
DAG?
can run a. Sorry.
Any kind of DAG?
Yeah, that also fine, right? You know, Airflow kind of thing, right?
Yeah.
Cool. Sounds good. So the idea is, guys, use any computation where you can run a Python script. In Kinesis, you cannot run any Python script. You need to write data to Kinesis. Remember that point. Okay. So wherever you
just
can write a
remember
Python.
Kinesis, like especially that Kinesis for streaming the data, right? The kind of live stream or stuff for Kinesis.
That is
Just trying to
completely
remember.
different area. Let's not get into Kinesis files for now.
Sorry.
Yes, because we'll have to go into completely different use cases for now. Okay.
Okay.
So
Okay.
wherever you can write a Python script and you can deploy it on some compute, you can use anything. You can use AWS Lambda, Airflow, Batch, ECS, EC2, AWS Glue, anything. Okay. But the main problem is you have TB's worth of data. AWS Lambda, wrong option. You can handle only 15 GB worth of data.
Yep.
Correct?
Yep.
Glue,
Yep.
yes. You can use PySpark. Airflow, yes, possible. But does your company, I'm going to take example of data engineer academies because we have already deployed the RAG bots, right? Let's say we don't use Airflow. So for me, Airflow is not the right option because I'm not using it. I don't want to invent it just for GenAI use case. Correct? So remember, guys, whenever I'm doing system design, I'm following data engineering stuff, even for GenAI. I'm listing down all the tools that can be used. And then I'm cross-verifying it against the requirement and my competence as well, or my team's competence. Okay. There is an option of Databricks as well, where I can run my Spark job. Now, I'm using Databricks, I'm using AWS Glue. Okay. This is going to be a tough choice, to be honest, if you ask me. But if I'm directly writing data only into S3, I might stick to AWS Glue. Okay, I might not entirely reinvent into Databricks, but I am going to come back to Databricks, guys. Remember this point, I will come back to Databricks. Okay. So let's say as of now you use AWS Glue, but there's another question. What about incremental data ingestion? Like, see, even if it's unstructured, you still need incremental data ingestion, correct? If new documents are coming into Drive, or let's take another example. We have Slack, correct? We have Slack messages. So what we are doing is we are ingesting all the Slack messages using API. Okay, all these are unstructured messages. So what we are doing is we are trying to feed these messages to our bot so that you can get automated answers. Because we have answered similar questions for multiple students, correct? Now let's take an example. You are taking Slack messages through API, through AWS Glue. Now comes the incremental data ingestion, correct? Like every day you need to keep on ingesting data and you need to write to your vector database. So same happens in any other design, any other RAG. Whatever designs you're doing, ask this question. Okay, so you're giving me documents. Are the documents gonna change? Do we have any new documents coming in every day? These are the questions you ask during system design. Or these are the questions when you ask yourself when you are designing a data engineering pipeline for GenAI project. Okay, because there can be never every YouTube video, every tutorial is gonna tell you only about static documents. They will give you 10 docs, 100 docs. They will show you how to ingest them into whatever system it is and then store it into vector database from local Python. But no one is gonna tell you if new documents are coming into source, how would you ingest them? That is where your data engineering skills comes into picture. Am I making sense, guys?
Yep.
It's a little confusing.
Yeah.
Is it confusing?
It does to me, it does make sense. That's so okay.
Got it. Keith, I think you said confusing.
Yeah, it's a little confusing.
Okay, no problem. Cool. Let's take an example.
Yes, that would be great.
I'll do one thing. Let me just close this. I'll show you some real systems. Just give me a minute.
You're going to show us an incremental system?
Can you hear me, guys?
Yes.
Yeah, you're kind of that good.
Yes.
You sound like God.
Sorry?
You're echoing.
Okay, let me show you some real systems now and real problem states.
I just want to say I really like Tom's bunny.
And
I know. I think I should.
Is that a bunny? Is that a bunny or a cat? I thought cat.
It's an evil bunny. No,
It's a bunny mixed with cat, maybe.
It's an evil bunny.
I just think of Monty Python with that.
Would that be even better? Yeah.
Okay, guys, let's take an example now. I'm gonna move into my laptop. Okay, so I am checking into. Sorry, I think my Slack is here. Just give me a minute. Let me open. I think Keith Sanks, right? That's your channel name, correct, Keith?
That is.
Cool. Okay. Let me get into Langsmith. I'll show you how the real system works. You will get an idea as well. I think you already have a support genie installed inside your.
I mean, in my the basic understanding is kind of like we need to have the flow that way. The data stream, it can be continuously updated as the system receives them, right? Okay.
You're right, but it's not streaming. You don't have to worry about streaming and that.
No. I'm not. In a sense, that would, I mean, flow. Like let's say data flow instead of saying streaming. Yeah.
Yep. Yeah. So let's take a real example. Okay. Let's say Keith doesn't understand I don't understand solution. Oops, sorry. I don't understand the solution provided for this question. Okay. Can you please elaborate? Will ChatGPT understand this part?
That's a good question. I've not thought
No.
that like, it would be able to handle a link.
They would not.
Now,
Okay.
how much? What's the information given? I cannot see it actually.
Right.
So-
What I'm giving is, this is Data Engineer Academy's portal. This is Data Engineer Academy's content, which is not available on ChatGPT, correct? The
So now
solution, this solution is available over here. ChatGPT doesn't have it, but let's say Keith doesn't understand it. Can you please elaborate? Okay, I asked this question to support Genie. What happens in background? This is the observability framework. Okay, this is what I use for observability in GenAI. Why did it here? Let's just refresh it. You see, the question has come here. This is the question. I am going to my database, that is Pinecone, embeddings and all those things. Okay. Based on embeddings, I'm going to find relevant document with respect to this question. Okay. So you see this? It's finding SQL FANG problem. These are my, I think this is part which is my metadata and all these things. Again, a very complex system. I don't want to get there. But you see this? It's finding all my Facebook related questions from this portal. Okay, so let's see if it is able to find this exact document. Yep, you see this? So it has, so you see what has happened, I'll tell you. It sent this question to my Pinecone database, a simple SQL statement with a where condition. That is what embeddings are. Okay, and then it actually got how many documents? 0, 1, 2, 3, 4. So it's going to take 5 relevant documents with respect to this question. And the most relevant document is the one which we actually have the question, correct? So you see the topic, user with top reactions. And that is the question we did ask, correct? Like user with top reaction. Now what happened? It's going to take all these 5 documents, all these 5 questions. It's creating a prompt out of it. Okay, so you see this entire question, answer, solution, explanation, background, everything. We take everything, we pass it to LLM. Okay, we pass it to LLM. Now LLM has a context. Okay, LLM has a context which is coming from Data Engineer Academy's portal. And then Keith gets an answer over here. You see this? Is it cool, guys? Do you understand how it works now?
All the 5 returned by LLM as well, or only the top one?
We send all 5. That is dependent on you. If you want to send all 5 or only top one. But usually we send 3 to 5. The reason is sometimes your relevant document can be ranked as 3rd or 4th. Now that is where re-ranking system comes into picture.
But based on the relevant, based on the ranking, there are 0.86. The first one is more relevant, right? Which means
Correct.
it gets the right question. Yeah.
Yes. So I think, did I explain ranking? Oh no. So I think I have some video shot for ranking. I haven't uploaded yet. There is a concept of re-ranking. Sometimes you have millions of documents, right? It can blur your, like I said, king, boy, human. They can have similar vector embeddings. Okay. How do the embedding looks like? I haven't really logged in into Pinecone for a long time. I'll show you how the embeddings look like. And these can be stored into Databricks or Snowflake as well. The reason I'm using Pinecone, it's very specific for my use case. And it's good for my use case. And Databricks and Snowflake are expensive as compared to Pinecone for me. That is the reason I'm going with Pinecone. Okay. So these are all the documents actually. These are the IDs which are created for the documents. This is the text inside of the document. Okay. Let me do one thing. That's fine, I think. So you see these values, guys, this is your embedding or a vector. So for this text is actually converted into a vector and it's stored into this Pinecone vector database. Okay, this is actually this is the product related. Oh no, I don't want to delete it. So in short, this is my database. Namespaces is my schema. My product schema has all the records related to SQL and Python. My default schema has everything related to Slack, but it's not for students. It's just for our internal team. But yeah, I know it's a complicated system. I don't want to burden you with all these things, but I'm just trying to show you how the database looks like and how the system looks like, because Keith was confused. Now, coming to the main point on the confusion, Keith, what I meant is, see, we keep on adding more and more questions on SQL, correct? Let's say FANG problems. Initially, we just had FANG. We then added LinkedIn, Uber, Walmart, Tesla, Spotify. We added a lot of companies. We are still adding more companies. Every week, we add more documents. Okay. Now, those documents needs to be replicated into my vector store, correct? That is what I was saying in my explanation. Every time, every project or other courses try to show you on a static document, thinking these documents won't change, but they will change, correct? They can change. You can get new documents. So you
eventually, yes.
So you need a pipeline that will ingest new documents or change documents into your vector database. Make sense, Keith?
Yes.
Kind of. So I guess I'm seeing how, okay, so the data flow, I guess, right? It goes from Slack to LangChain.
No, that is another system. Don't worry about that. That is like API Gateway, Lambda, SQS, lot of other things. Yep, lot of other things. But I'm trying to show you the initial part. See, this is the final part. Right? The question goes, and then it retrieves the relevant documents from my vector database, correct? But before even doing all these things, you first need to store all these documents into vector database, correct?
Yes.
And that is the part we're trying to learn. And that is the part of the system design we're trying to learn. The part from Slack to all these things, that is secondary part. Okay, first part is, all these documents first needs to be stored into your vector database, correct?
All the documents need to be stored in the vector database.
Correct.
What do you mean?
He has to be done incrementally, right?
Yep. Now, what do I mean by that?
Yeah.
These questions, they need to be copied and pasted into your vector database. That is here.
Where does that vector database lives?
Sorry, I didn't get your question.
So where does that vector database lives?
It's a Pinecone. For me, it's Pinecone. I have stored it in Pinecone.
So Pinecone is the database.
Yes, Pinecone is a database.
Okay.
So product, search by ID. This is my ID. I'm going to search it. So you see, this is the chunk. This is the text. So this text, if you see here, it's exactly copied from this part.
So Pinecone is able to, I guess, crawl. Is it able to crawl?
No, that is the data engineering process I have built.
Okay.
It's not going to crawl. What happens is, whenever we create a new question, we store it in a Google Drive.
Okay.
What is the drive name? I forgot the drive name.
So it's not a simple import. We actually have to process the data and generate the vector to go into the vector database.
Correct. Exactly. So what happens is, whenever the new questions are added, one of my support staff they create a document and they upload it into Drive. And then I have a data engineering pipeline running on top of Databricks, which runs every week. Okay, let me go back to Databricks. That is why I told you I'll come back to Databricks. The reason I won't be using Glue and I'll be using Databricks. So let me just log into Databricks. But yeah, there are options. You can use AWS as well. You can use SageMaker. You can use Glue. That's not a problem. I felt Databricks was the right solution for me. That is why I've used it. You can also use Snowflake, by the way. Let me just go back here. So I have a workflow which runs some notebooks. Here, I have some notebooks over here, which gets the data from my Drive. Okay.
Okay.
It chunks them. Chunking is something else. I don't want to get into chunking for now.
I know. I can understand what chunking is. That's like where it tokenizes basically the document.
Yep.
Yeah.
Yep. Again, just for everyone, I don't want to confuse you guys with chunking. We'll cover that in next topic or next lesson. But what we do is, whenever we add a new question, a support staff adds a document into Drive. Then every week, my Databricks job runs and ingests that data into AWS S3. From S3, I chunk it. I create embeddings. From embeddings, it goes back to my vector database. This is the data engineering pipeline, incremental data engineering pipeline for GenAI.
So what's actually in the vector?
You see this entire thing? There is an ID, there is a text, there is a level, modified. When was it modified? Update date in short, a path, subject, topic. You can add any kind of metadata you need. These are the metadatas I have added. Okay. This is a vector database, data modeling kind of thing.
So it's a key value pairs.
In short, yes. But apart from that, you get a vector as well. You see these values? These are all the things you get. So you get an ID, you get a value for this entire chunk.
So that's the schema that you determined?
Yes, correct.
Okay.
This is the schema that I have designed.
Yeah.
Okay. The reason I have designed because so you remember what happens when I ask the question. Some folks send this link, correct? Some folks don't send this link. They just type in, I don't understand a user with top reactions. That is why I have covered all those things. So you see here, I have the link over here.
Okay.
In my text. In my
this is like really helpful, man. Like this is like I'm really learning from this now. Keep going.
Yep. I mean, yeah, that's what we have this in our GenAI module as well, but just wanted to show you guys the data engineering part of it.
What does this chunk represent? Like what
So
what exactly does this vector that we're looking at, the chunk, like what does that represent?
Let me get the document for this. Where did I keep those documents? Yeah.
These embeddings are created by Pinecone, or it is done before?
That's a transformation logic. I usually use OpenAI, but there are a lot of embedding creation frameworks available in open source as well. I use OpenAI for that. So it's a simple Python script. Again, we are going to get into deep, but just to show you guys how embeddings are created. This is an embedding notebook. I store all my Slack messages into a table. Okay. And how embeddings are created, this is the logic. That's as simple as that. So what I do is I get the text, I clean the text, and I pass it to OpenAI embeddings.create. I get the embedding, and I then append it into my vector store. That is Pinecone. That's it.
Okay, so you defined it in Databricks, like your Pinecone and your OpenAI.
Yep.
So what should you import to use OpenAI?
You import OpenAI, no, that's it. OpenAI has all those things.
Okay.
That is why, guys, don't worry about this part for now. I don't want you to burden with all this knowledge for now, because it's going to take multiple classes. I want you to understand the pipeline of ingestion first. Forget about transformation. I just did show it because someone asked the question, but don't worry about it. Just try to understand the extraction part for now. The way you learn data engineering, extraction, loading, and then transformation, I'm teaching you similar fashion. How would you do extraction and ingestion in incremental fashion? Make sense? Don't worry about transformation for now. We'll reach there. We'll go there.
Can you answer my question about the vector? What does one vector represent?
Okay, yeah, I'll show you. I'm just trying to find that document. Where did I keep the document?
I think it's a lot like a checksum, but a little more complicated. Basically,
it almost looked like a SQL query. I don't know how else to say it. Like,
yeah. So okay, I'll tell you what happens. We copy this. Okay. We copy the solution. Okay. Sometimes there is a video attached to this. We copy the transcript for that video. Entire text is stored in one document. Okay. We break that document and then it comes into this chunk text. So if you see here, this is the background of the question. Okay. That is nothing but, if I go back here, this is what. Okay. So it's nothing but whatever you see on our portal in the text format, all those things are coming into my chunk text. So this is the background. Okay. After background, there are table names and all these things. That's nothing but this part. Table names are case sensitive, right?
Mm-hmm.
And then there's where did it go? These are table names. Do I have a solution? Do I have a solution anywhere? Yep, here you go. So we have a solution.
but it's not it's not like it's arbitrarily like just cutting. Like the chunk is not just like arbitrarily like cutting off. It's intelligent. Like every vector is going to look the same. Is that correct?
No, not really. Intelligently, yes, you can do that as well. But I have done the arbitrary one. Okay, whenever I did cut it. So see, that is what data engineering comes in picture, right? Like, I know the SQL FANG questions can fit into one chunk. Okay. But if I go to SQL tutorial, let me go to SQL tutorial. SQL tutorial cannot fit into one chunk because there is entire video explanation as well. Let's see if I go to practice question. Not here. I think there are some videos in some tutorials, right? Not in practice questions. Let me go to beginner lessons. If I go here, there is a video over here, correct?
Yes.
This entire stuff cannot fit into one chunk, along with solution and video explanation. Correct? That is where you as a data engineer, by researching, by understanding your data, you need to understand how much your one chunk should be. Okay. So in my case, my one chunk, where did it go? This is Slack message. That's why you see this over here. Where did I write that notebook? Where did I write that notebook? My one chunk is of 500 to 700 tokens. Just to tell you, I don't think I have the notebook handy as of now, but that is based on the analysis what I have done. For my use case, 700 tokens. 700 tokens is nothing but almost 704 words, right? 2800 words is a good number to have into one chunk text. That is what I understood that number after analyzing my data. You cannot decide it over on the fly.
Yeah, say that again.
You cannot understand that on fly. I have 2800 words as my chunk size. That is based on my documents, because what I am doing is I am having SQL tutorial and Python tutorial in my vector database, correct? So what I wanted is, I wanted all these FANG problems, questions, solution, and explanation in one chunk size, because I don't want to break them. I wanted them in one chunk size, and based on that, I decided my chunk size. Okay, but My SQL tutorial, this is a huge one.
Is there a place
Right?
where you had to define your chunk size then?
Yes, we do that in transformation.
Okay, gotcha.
Yep, we do that in transformation. But yes, lot of things to decide in transformation. Don't worry about it now. We will cover them for sure.
Right.
The only thing what I wanted to show you guys, what is RAG, how it works, what is important for ingestion. Ingestion, you can use AWS Glue or Databricks. The reason I went for Databricks, I want to tell you, after ingestion, I wanted to do transformation as well. Correct? That is the reason I went for Databricks, and Databricks is good for ML or AI use cases. I would have went for SageMaker, but I have everything under Databricks. I can do workflow scheduling, dependency management, AI stuff, data ingestion, everything. That is the reason I chose Databricks over Glue. Makes sense, guys? That is how I decided to go over Databricks. So yes, I know we are beyond time, but I hope you learned something new on designing ingestion pipeline. You haven't designed the entire system yet, guys. Don't worry about that. But I'm open for any questions. I think last few minutes.
So when we conclude regarding the title you gave, like DE in AI, right?
Sorry, I didn't get the first part of the question. What did you say in DE in AI?
Yeah, the title you gave it for this section was DE in AI, right? Data engineering in artificial intelligence. So, of course, the example was related to data engineering academy, but it was in general, right? You mean
yes? Correct. Yeah. In general, you have a document, right? You have hundreds and thousands and millions of documents. They might not be in Drive. They might be somewhere else. You as a data engineer, your goal is to work with unstructured data, unstructured documents, ingest them in some landing zone. So whenever you're designing, make sure you have a landing zone before storing it into vector database. And how do you choose? You can use Python. Wherever you can run a Python, that is a better system. But just don't decide blindly. Remember, you will have to do transformation as well. Now that's where I did show you an example of Lambda, Glue, and Databricks. Lambda cannot be used because 15 GB limit, and I wouldn't really use it for ingestion. Now there is a competition between EMR, Glue, SageMaker, or Databricks. The reason I went with Databricks, company already uses Databricks, and it's good for all the use cases. That is why I went with it. You can do it in Glue, not a problem. But as a data scientist or a data engineering, or AI engineer, Databricks is a good solution for me. That is why I went for Databricks. So yeah, that is what we explained today.
Why is Databricks a good solution for you on that? And you're chunking automatic?
You mean as compared to Databricks? Oh, sorry, as compared to Glue?
Yeah.
Yeah. So see, what happens is Databricks has a notebook style development. First thing, Glue also has it. I agree. But installing multiple libraries into Glue is a nightmare for me. Installing libraries. So you need a lot of libraries to do this work. It's not just one library. You need at least 20 to 30 different libraries. Now, Glue has a limitation of 250 MB worth of libraries. You cannot install more than that. Okay, that's first thing. Second thing, if you want to schedule the notebooks and you want to see the output every time, then observability. Databricks has it better as compared to Glue. Second thing. Third thing, if you want to use some inbuilt models from Databricks for embeddings or for anything else, Databricks has it. AWS Glue doesn't have it. Like creation of embeddings, correct? I use OpenAI, but Databricks have their inbuilt embedding model as well. You can use their inbuilt embedding models.
You can use AWS SageMaker or Bedrock or those, right?
Great question. SageMaker makes sense, but SageMaker is not good for data engineering stuff.
Okay.
Like incremental data ingestion, correct?
Okay.
Every day I need to schedule the job. I need to ingest the data from Drive or API-based systems. I need to store it in tables as well. So remember, the landing zone is nothing but I'm storing it in a table in Databricks.
Yeah.
I'm not deleting it. SageMaker is not good for that.
Okay.
SageMaker is just good for the ML side of it. Okay. I think second part, AWS Bedrock, good, no-code tool. You don't have control. You don't have control of ingestion part.
Okay.
For the for the load part, if your landing zone is Databricks, are you using Databricks? Are you writing a script in Databricks to take it to the your vector database?
For me, okay, so again, why did choose Databricks? Databricks stores data on top of S3. So no database required. Everything is stored on top of S3.
Right.
That is another good solution for me as well. And I decided Databricks, another reason, I had thousands of documents. I wanted to partition and do all those things as well. It was easier in Databricks as compared to Glue. That is why I went with Databricks. Bedrock is a good solution for POCs, but it can get really expensive pretty soon. Just FYI. I did use Bedrock as an initial use case, but what I've learned is go through coding, code it yourself, design it yourself, understand the fundamentals, and then these services like Bedrock, Azure, OpenAI, they are easy to understand. If you do it from scratch, without using these no-code tools. So yeah. Cool.
Is that what they they're like projects? Are they? Do any of the projects go over this?
Not into gold modules. In GenAI module, yes, we do have. That's an additional one.
Okay,
if you already, I think some of the folks who have bought GenAI, they do have access.
So you got so one more question on the load. So you're going to be looking for your type of data for whether you're going to use chunk size or chunk underscore size, and whether you're going to do it as a characters with overlap or not. And stream if it's a video, like a video.
No, video, you don't store direct videos. You convert the videos to text, and then you store the text. You take the transcripts out of video. You don't entirely store the video. We convert the video into text transcripts, and then we use the similar thing what you said, chunk, overlap, and those things.
If a video has, just as a hypothetical example, if a video, let us say, has no audio to it, even then we can take a transcript and process.
Sorry, what did you say? Video doesn't have anything? I didn't get it.
No, my question was if just as a different scenario, if let's say there's a video which has no audio, just a video, can that also, can you get a transcript of that and process it, or do you have to do something different?
No, so what we do in that case is we convert the videos into multiple image frames. Like, let's say if it's a 10 minutes video,
you
write a code using, what is that? YOLO, or there are some YOLO, or there is some other library where you convert the video frames into image frames. You can capture the frames at every second or every 2 seconds, depending on your use case, correct? Because you know the video, correct? If it's a 10-minute video, huge video, based on your business requirement, you can do it every 2 seconds, 5 seconds. Capture the videos, convert that videos in, images, capture the video into images, convert that image into vector, convert that, send that image vector to OpenAI, and convert it into text. In short, whenever you upload an image on ChatGPT, you can get a summarization of that image, right?
Yeah.
You do the exact same thing for the video. You convert the video into images, send images to multimodal models, and then get the summarization of that image. Like, tell me what's happening into this image. Summarize this image, right? And that's how you convert it into text. We do have that example as well, just FYI. I mean, our videos are converted in a similar fashion. But some use cases, don't need to complicate that much. But yes, makes sense if you don't have audio and those kind of things. Video to image, just FYI. So related to this, I'm developing a SQL AI interviewer. It's doing similar thing. Whenever an AI interviewer joins your call, you're writing a SQL. It takes a snapshot of what you're writing into the SQL every 30 seconds, every 20 seconds. It converts that image into text using multimodal and then summarizes it, and then it processes it. So one of the use cases for video to image to text.
Sounds good. Thank you. Thank you for your time today.
No problem. Any other last questions, guys?
Well, I was just looking at how chunking was used, and it's like a different library for each kind of chunking you do.
Yes, there is hierarchical chunking. There is contextual chunking. There is embedding based chunking as well. LangChain has a lot of them. Right?
Yeah, Pandas, LangChain, requests, multi-processing library.
Yep, a lot of them. But usually you use document splitter. And it's based on some specific chunk size. And that's why you have to analyze your data, right? When you analyze your documents, you understand what chunk size is better for you. So yeah, there are a lot of ways to do that. I studied it quite a time ago, but there are a lot of chunking engagement. And some of them are theoretically good, not practically good.
Say that again.
Some of them are theoretically good, but practically they don't really.
Are you saying practically good?
No, theoretically good, but practically they don't work. Like fixed size chunking, right? It's good in practical. Theoretically, it might not be good. Let's say semantic chunking. I realize semantic chunking is good in theory, but when I get into practical, it can get expensive pretty fast.
Semantic.
Yep. In short, you understand the meaning of the document using AI. You pass the document to LLM and ask LLM to create the embeddings by understanding the meaning of the document. So yeah, it can get expensive pretty soon. Also, if you have entire document into one chunk, that also can get expensive because now you're sending entire document to the LLM, correct? So yes.
So in that case, what would be the best strategy?
See, practically for me, it's recursive or fixed size. At least for me, as of now, practically.
Recursive or what?
Fixed size.
Oh,
okay. Yeah, fixed size. So let me do one thing. Just for you guys, I'll have to drop off in a minute. I have a call. Go through this document. This is from Databricks. This is what I use to understand some concepts on chunking. There you go. These are some types of chunking, and you have a code as well. That's good, right? Fixed size, where you mention the chunk size and chunk overlap. This is not actually a emoji, it's actually closing bracket. This is semantic chunking. This is based on LLM. Don't worry about this part for now. And recursive chunking. So what is recursive chunking? Based on high-level splitters, code splitters, like, It can understand code. It can understand JavaScript, Java. It can even understand Python. It can even understand JSON files, Parquet files. Based on file type, it can do recursive character text data. Okay, so these two are widely used. That's what I feel. But yeah, go through this document, go through this blog. It should help you understand more. Cool. I hope this was helpful, guys. Let me know if you want anything else. But yeah, next session, I think we can cover the next part of data engineering in AI.
Thank you, Nina.
Thank
So
you.
thank you all.
Nilan,
Yes.
so Nilan, what are you going to cover next session?
I think we covered the extraction part, right? We might cover loading and transformation part in
Loading.
data
Okay,
engineering.
okay, thank you, Nilan.
Yep, no problem. Thank you all. Good day.
Yeah, I can't find the chat in here, so.
No problem. Just ping me. I'll send you the link.
Okay.
Cool. Thank you. Good day, guys.
All right. Thank you very much. Have a nice day. All right.
Okay, so that's the project breakdown. I hope you enjoyed. And if you are interested in learning more projects just like this, so you can learn a bunch of tools and walk through a bunch of real life projects so that you can put in your resume and so that you can feel confident talking about these on the interview, then click on the link below and see how you can work directly with me and my team at Data Engineer Academy, because we've already helped over 2,000 people just like you. And all you have to do is click on the link, book a call, see what we have to offer. And if you don't want to work with us, all good, no worries at all. But if you do, click on the link below and let's see how we can help. Cheers.